All right, guys, we're going to go ahead and get started. Today's, February 17th already, so we're halfway through Februage. Tonight's agenda is pretty simple. We're actually going to do a couple of slide decks, and that's pretty much going to round us out for tonight. We actually have some audio-visual stuff, too. So this is kind of the YouTube version of the class for the semester, and we'll watch that. I kind of forgot that since I've never replaced my microphone, because my phone's been working out probably better than my old microphone, that I'm going to have to mute part of this. So you guys online, I will actually be muting you out, and you'll need to actually watch the videos using the link. And I'll explain that whenever we get to the first one and that type of stuff. And hopefully I don't blast this out of the classroom. I was trying to get the sound to work nicely in here. So that's where we're at, basically looking at the schedule. We're on systems analysis and fact-finding techniques. Next week, we're going to start doing use cases, and we'll run those for 2 weeks. We'll talk about the midterm, and I know there's a question. So what was your question about the midterm? No, that's fine. So what I'm looking at for the midterm is essentially it'll be on that day, and I'll probably just release it for the full day.
Yeah. So wait, I have class like a couple days, and then you want to stick it like this time, or maybe you have to have like the next day, like earlier. It's a suggestion, but.
So you'd like some more flexibility as far as the day?
Yeah.
Okay. All right. I'll have to consider that.
Okay.
I need to know what I can.
I'm just saying, like, I'm just saying, but.
Yeah. Okay. Do most of you have classes all day too? Yeah. I figure you guys are all on the same schedule, so I can be fairly flexible. So let me take that back. I got to see what I can do. Put it out there. So no promises, but yeah, I'll take that under advisement and do it that way. So so yeah, and then basically I'm starting to fine tune basically the project and also the midterm as far as how I want to run it. So next week I'll actually have some answers for you guys on some of those questions too. So, and that's pretty much housekeeping. Any other items? Okay. A lot of you were gone last week, so make sure you go back online, view the lecture. If you're going to miss classes, don't worry about it. You don't have to let me know. Just go ahead and just catch up with material. That's the nice thing about having recording utility is everybody can get a hold of it whenever they need to. So there's lots more people than what's in the class and what's online. So I am assuming that I already sent my warning, email for the semester. So kind of your tough luck if you're not keeping up with everything. So we're all adults here at this point. So all right, that's pretty much my agenda tonight. So I think it's going to be pretty lightweight. We'll see how long we go. I do think we'll probably end up using most of the time, just because there's some of the material is just a little bit more in depth as we start to go into it. And as we go into the use cases, you can expect us to go the full class period too. So we'll start approaching 8. I usually stop at 8. I don't go to the full 10. So, and that type of stuff. But we're just going to ramp up. We're actually next week we're going to break out Visio again, and we're going to do that in detail around use cases. And we'll start designing some systems at a very, very high level as we go through this. Yep.
So if because I wanted to do it, like have it on my laptop.
Yep.
You can do the
To actually start the subscription.
Yeah.
When does your semester end? May 10th. So today is what? February 17th. You could probably start now.
Okay.
Because you basically would be going February to March, March to April, April to May.
Okay.
And then that'd be 3 months. And I can't remember what I put in the email what the subscription rate is.
It's I checked. It was like $15.
It's like $15. That's $45 for the semester to get you through the semester. I mean, so, and hopefully most of you took advantage of the book race and that type of stuff. So you haven't paid much for books. So maybe you use it on the Visio side. So, but really, I mean, you can stretch that out even if you want to try to go to the midterm and use it then. That's up to you. Whatever you feel comfortable with. It's in the computer lab too. So if you want to balance, however you want to balance.
I have to use it for like my stuff too.
Yeah, if you have other needs, and that's why everybody's in a different boat as far as what to do as far as the solution goes. So, and does anybody subscribe to that already? That just gets added to your office, is my understanding. So it's just part of your account, and it should just be there, and that type of stuff. It's just like you install Word and Access. Do you guys actually get Microsoft Access? I don't know if I've ever gotten a clear answer on that or not. You do. Every student gets Microsoft Access.
Yeah, if you use like the office.
Yeah.
Or through your school. No, yeah.
Okay. Okay. All right. I always got mixed answers on that. With Max? Okay. All right. Were you guys in 542? Okay. Oh, from the other course. The first one, or the first course, whatever that's called. Okay. Yeah, that thing. All righty. Any other questions? Those are good questions. All right. Well, let's dive into systems analysis. I'm going to do the systems analysis. I'll cut the recording, and then we'll switch over to the fact finding. So systems analysis. So that's essentially the name of the course, right? If we step back and think about it. So what that really does is, again, it's hard to read on the projector up here, but if you look in the front of your book for this chapter, essentially what it's taken us through is all the way from the point that we identify the problem, which is really the statement of work at the top, and we talked about that last class and the class before that, through business requirements, really to the point that we have a system proposal. And this is essentially what I'm asking you guys to do this semester, is that top half of the box is what actually is applied in this course. So we're going to take you through basically how to put together a system proposal of a particular type. So that's going to be essentially what we're going to do, and that's really your fundamental decision point as far as whether you're actually going to go forward and actually either spend money on purchasing a solution or actually spend money and time and resources on building it. Oh, can you guys mute if you haven't already? If you're not going to be speaking, please mute. Got some feedback there. So essentially, that's the ultimate crux of the course. That's what you're really going to be applying as we go into the semester. And we need to remember there's building blocks up here, right? So we went through that now probably 2-3 weeks ago, where it's really, information being, data, information, and knowledge is in the green here. We have really the processes and policies and procedures of the organization or whatever the system's going to be handling here in the tan. And then the other piece over here is in purple is really the communication. And that came in 2 aspects. There's the communication in the sense of how does the user interact with the system, and also how do 2 systems interact with each other. So there's kind of that, think of it as a computer-to-computer type communication as we go through it. And we have all of our different players over here. So we're acting as a systems analyst. Last week we talked about being project managers. And but for the most part, the rest of the semester, we're really going to be concentrating on what does it mean to be a systems analyst, and really starting to hone in on that as we go through it. But a systems analyst always has to wear those other hats. So we got to step back and sometimes put ourselves in the shoes of those system owners. Are going to be the people that are going to fund our system, or the system users are the ones that are actually going to be touching the system on a daily basis. We have to think through that. And then we've also talked through that there's a process around doing that. So we've gone through and identified kind of a problem-solving technique that has 7 stages, and that's what we're going to walk you through. The first 5 is really considered the systems analysis portion of that. So, and that is what systems analysis is. It's really how do we go through and actually solve a problem. So last week and the week before, I kind of mentioned a couple of terms. I always use this word called functional decomposition. And that's really this idea that we're going to break down this big problem that an organization has into smaller bits and pieces. Because the smaller bits and pieces are easier to solve for. So it's a divide and conquer type strategy. So you may have something where it's like, well, I don't know how to solve that. You ask me to, say your project ends up being, okay, put forth a proposal for a patient portal system for a hospital. Well, that's a big question, right? How in the world do I wrap my head around what a patient portal should have? That's what systems analysis really does, is it says, okay, how do we take that problem or that issue, break it down into all of its bits and pieces, and then really step back and solve those individual bits and pieces so we can solve the entire problem as we go through that. Systems design is really then, once you've kind of picked that solution from your analysis portion, how do you go through and actually put put that system into play that actually solves it? So that's essentially where you're putting basically the system together and saying, this is how we plan on solving it. Here's the actual, bits and components that actually solve that as an entire system together. And what we're doing is we're always concentrating in the information systems arena. That's the core of this class. But the idea here, though, is even if you don't give 2 hoots about information systems, it's okay. You can take this discipline and very much apply it to anything that gets put in front of you. Because you're always probably going to be, if you're management, you're a problem solver by definition. A lot of times what you're doing for the organization. And you can take this methodology and basically apply it to that. So again, those first 5 pieces were basically the systems analysis portion. So we had scope definition. We kind of walked through that. We're getting into problem analysis and requirements analysis is where we're going to spend a lot of time. Next week, we're going to move into logical design with use cases. And then at one point after your midterm, we'll actually come back and say, how did we make this decision? And that's called a lot of times feasibility analysis and what makes the most sense for your system or for your organization to pursue as far as the system goes. These other boxes over here are really the design portion, and then you have your maintenance and operations going forward off of that. So a lot of this, I've heard a lot of you guys talking about your internships and stuff ahead of time. One of the things that you always kind of start up whenever you start up a project is you should also be starting a repository. So this is just something that's small, but it's just really useful to do. Is just start a location where you're going to store everything. So as you guys start up your groups, start a project repository. It's where you stick all your background research, all your materials that you're generating, if you generate a statement of work, you throw that in there. If you collect some business documents, you put them in that repository. And that's really just a central location where everybody can go to and that type of stuff. I'm always surprised at how many people just don't even think like this whenever, we get like interns or new employees into the organization. It's like, yeah, go put everything into the shared drive because you're not working alone. You're working in teams and working in a department where other people need to get. So that's one of the first things that you kind of set up as you get into it. And then what we're going to do is we're going to basically move through what's called model-driven analysis. And so we're actually going to be creating a lot of models. And models are really just representations of the real world, right? So if you think about a car and the model that goes along with it, it's a representation of the bigger car and that type of stuff. And really the model is the blueprint that we're building in order to actually create the system. Now, sometimes our blueprints aren't quite what you guys think of blueprints for IT systems. We're very non-technology specific. We're basically looking at it from a business problem and saying, how do we solve the problem from a business lens first, and then apply the technology as a secondary factor to the overall issue. And so that's essentially what we're going to be doing is, and we'll teach you some model type approaches to this. So use cases, what we're going to see next week are one, activity diagrams are another. And these are generally useful too because you can take these models and apply them to any work that we have. Like what I do at work is a lot of business process stuff. We take this stuff and we actually apply it to stuff that isn't even IT related at the end of the day. And so what we have is basically then there's lots of model-driven approaches though. So as you go through it, and we kind of saw this in the first night, you guys probably don't remember any of that, which is okay. But basically, when you get into an organization, everybody has their own approach around doing stuff. Or some organizations don't have any approach, as we kind of talked through with the capability maturities model. And so we'll go through, and we're actually going to use basically a modeling approach that's called UML, which is at the bottom of this block. And that stands for Unified Modeling Language. And really, this what happened in the old days. What models used to consist of is you have a data model, and then you have a process model, maybe a communication model over here, like state diagrams and stuff like that. What ended up happening is actually three of the major guys that were kind of proponents of model-oriented problem solving got together and actually created this unified modeling language. And they basically combined all of their approaches into one, and now it's called UML for short. And that's essentially, we're going to teach you three diagrams in the UML suite, and there's about 13 diagrams in that suite as we go through it. And so, for instance, this is an older version of a process model. And so what really a process model would do is show you what's all the different components of an overall process. And so what you had in here is you had, processes can't be separated from data, and data can't be separated from processes. They go hand in hand. One of the things I've been teaching folks at work is essentially, we were talking about data quality, and data integrity is kind of my job now. Going through and actually think about it, a process will generate data. Data will never generate a process, right? But they go hand in hand because you need data in order to actually execute your process. So what we have here is this idea of how do we actually process orders. And this is just a version around showing how does this organization do orders. Now your textbook, even though I like it, is data, right? So it is, basically, they're talking about actually one of those old subscription type services where you used to, it's like, hey, you can get 11 CDs and you only have to buy 7 more at full price. And then then basically you get these in the mail. Does anybody remember those things? You do? Okay. Yeah, it was like Columbia House, and I can't remember the other one. It used to come out of Terre Haute, Indiana, I remember. There's like two major, what was it? Yeah, Disney still runs a thing like this. We just got one from Disney the other day where it's like, hey, you can buy 5 Disney movies from the vault, and you only have to buy like 3 more at full price or whatever, and they'll send one to you every month too. And then they're hoping you never return the one on a monthly basis, so you end up buying them. So so that's actually if you go through the book, that's actually the company that they give you. So they're talking about CDs. Nobody even buys CDs anymore, right? You guys buy CDs? You do? I do too, but I figure and then I think they're even talking about probably tapes and stuff and stuff. It's kind of that old. But that's the idea here, and what they're doing is they're going through and actually processing orders. And so what you see on the top here is you have different entities that are involved in the business process. So here they have a club member because it used to belong to the club. It's kind of the way it was. So you got a club member here, this represents a club member, and then you have a warehouse down here. And so then what you have is you have these pieces, which are basically places where they're storing data. We don't say what type of database it is. We don't care about the technology. We just say, hey, there's a place where we're storing accounts, and there's a place where we're storing orders. And essentially, those are the components that then go with each of these processes. And so here what they do is they actually just have the generic, hey, we need to process member orders. So that's probably more of your generic order. It's just like, the regular one that happens on a monthly basis, that type of stuff. Or actually, sorry, that's probably just one where you submit an order and they're just going to process it. Over here on the left-hand side, they have the automatic orders. That goes back to the, hey, we're going to send you a DVD or a CD on a monthly basis, and that we're just making that, saying that goes by time, and every start of the month we're going to send that to you. That's an automatic order. And then in here in the middle, they have these bonus orders. So maybe if you purchase so many things, then you get, an extra free CD out of the company. And basically that's what's in the middle here in this rounded rectangle. And so each of these symbols actually has meaning to it. If you notice, all the entities or all the people involved or all the things involved, all are basically in square boxes, right? And then basically the processes are rounded, and then the basically the data components basically look like this, with an open-ended rectangle. And so essentially what's going through here is they're showing, as you do these processes, what is the flow of the data that goes between each one of these. And in most systems, what you have is each one of these order processes, you can actually drill into them. Maybe not automatically. Some software will actually let you double-click on them, and they'll actually tell you here's each step that's involved with processing that type of order. Sometimes it's, well, go reference this document, and it's got the steps inside of that. But essentially, that's what they're doing with this model. But the idea here is that we've taken all that stuff and made it into a picture. So what can I tell about this business? One is I can tell that they have members, club members, right? So they've got some type of membership model going on with this business. They have different types of orders. I can kind of make sense that, hey, they've got some type of bonus scheme going on, and they've got some type of automatic order going on here. And I can see the different data that they're sending back and forth. And so what we can see here is, with the with what's going on, they're pulling in this data as part of this process. So here's basically the member order puts in basically a member comes along, they put in an order at the top here. It flows into this process. At the same time, they're taking your credit rating and limit, and they're probably doing a check just to make sure that, hey, you've got your card on file, like your credit card, or is it still good? Can I actually still process that order against that card? Kind of like when you go online and order something, you always kind of stick a card in, and then they'll run it and see, knows if there's any issues or mistakes or anything like that. So basically, those two things go into the process, and what comes out of it are these two lines coming over here. So we have basically orders going into this order database, but it also gets sent off to the warehouse. So there's that direction of the flow as you go through it. If you guys online, if you're not actively speaking, if you can mute, that'd be great. We always have issues with the quality with the recording, so we appreciate it. And it's *6 too if you don't know the key sequence. And what we have here is basically orders to be filled. So that's going over to the warehouse, and in the warehouse we have a process that's probably about fulfillment. How do I actually fulfill an order? And that's on a separate diagram. So this is an example of an old process diagram as we go through it. Here's a data model diagram. These are actually still very popular too. The previous they call these data flow diagrams. They're not used as much anymore. What I'm going to show you with the UML models is used much more frequently in today's world. These data models, though, are really used quite extensively. They call them entity relationship diagrams. We drill into that in 542. You actually have to create these models in that course. And really what they do is they tell you what is all the data you're going to collect, what are all the individual data fields for each member, like their name, their address, all those types of information that you're going to collect for them. And they tell you how all the data gets related to each other.
Isn't that like the same way we put them into access?
Mm-hmm.
Yeah.
Yep. So, and that's a great point, because what these models are for is we are going to turn this into IT systems, right? So this data model ends up being your database diagram. And what you do there is you translate that into an actual database. And in 542, that's what you're actually going to build. You actually will be able to build a real active database that's functional. These process models on the previous screen, those usually turn into your screens and your business logic. So you actually will have programmers that say, hey, here's all the steps around doing an order. They actually put that into code and they build screens around it, so that way your staff could basically go through and process those orders. And so I'm glad you brought that up, because that's the direct link between where we're starting and where we're going to end up with as we go through it. And then what happened is basically over time we combined the two concepts together and basically into what we call an object model. And here what we're doing is we're saying, hey, we've got the data and the processes side by side. We don't have this kind of separation between them because they go hand in hand anyways. And so the way you read these is it's kind of a blending of the two, but you got to kind of understand how to read it. So here we've got some type of, maybe it's a information system for a university. And here on the left-hand side we have a student, on the right-hand side we have a course, and down here we have a transcript. So the student here has data points, which is in the front or the top half of this, and then they have processes that they can execute underneath it. So basically, some of the data we want to collect is an ID number. So you guys have your, what is it, your PAWS ID, is that what they call it here? Or student ID? Okay. You have you have a name, and you have your grade point average. That exists within the student's object. And then what a student can do is they can be admitted, they can register for a class, they can withdraw from a class, or maybe withdraw from the university, so I'm clear what that one is. They can change their address, they can have their GPA calculated, and they can graduate, whatever they hope for, right? Some of you are going to be done after this semester. Over here on a course, they have what is the subject of the course, what's the number, what's the title, how many credits is it worth. That's the data component of a course. And what we can do with courses is we create one, we can delete one, we can change it over time. Those are the processes that go along with the course. So that kind of makes sense? And then basically they're combining it together, and then they show relationships between these things. And down here we have the transcript, which is really, kind of the intersection between a student and a course, right? If you think about what's on your transcript, have you guys ever seen your transcript? You got all your student information at the top, and then it lists each course and what grade you have, right? So here we basically have what's the semester, what's the division, what's the grade. You can basically have a course that's added, dropped, completed, and a grade change and that type of stuff. And we know these things are linked between these lines. So you can kind of think of the lines as bridges between all the different data and processes that go together. So that's what we're going to basically be doing, is we're going to kind of come from this from an object-oriented perspective. You'll see this later on in the semester. The use cases kind of boil all this up and kind of hide some of the detail, and it's kind of nice to do. But a lot of times what happens in today's world is what we want to do is be very fast as far as producing something as far as our information systems go, and start to get some feedback on it. In the old days, we kind of followed what was called this waterfall approach, and it's like you went through all these steps without, basically trying to get all the requirements up front before you ever, actually produced anything that anybody could look at. A lot of times in today's world, what we're doing is we're actually building small-scale, incomplete working systems called prototypes, so that you can actually put your hands on it until basically get feedback of whether it's right or wrong. And so a lot of times you see that, and those are really great because a lot of people don't necessarily know what they want until they see it, right? It's like, well, yeah, I want a system that does this. But once they see it, they're going, oh, yeah, that isn't quite what I meant. I actually meant this. Or could we add that? That would actually make this work for me. And that's what allows you can get that feedback with a prototype because you actually can put something in front of it, and you do this. And that's a good approach around it is basically doing what we call discovery prototyping, and that's where you get that type of feedback. Now, there are some issues with that. Is basically what people can do is they can think, number one, is that, hey, you already built this. That must have been easy. We just started talking about this, and you already delivered those small example systems to me. Well, it must not take you that much longer to produce the real system. Well, this system doesn't work, number one. It's just some screens and some hiding stuff behind the scenes and just basically allowing people to get a sense of what it's like. So it doesn't have all the business logic put into it. It doesn't have all the security. May not have a full-blown database behind it. That type of stuff as it goes through it. People also sometimes, if your screens don't look really nice, get stuck on, well, that's mistyped and this doesn't quite work the way I thought it would as far as the drop-down goes and that type of stuff. So they get preoccupied with the look and feel of it as you go through it. So those are a couple of things that you just got to be careful with prototyping. Some other things that you can do too is if you have existing systems, you can do what's called reverse engineering. And so that's not necessarily a bad thing too. And we kind of talked about this. Legacy systems or systems that have been around forever are typically good systems because otherwise they wouldn't have been used for so long. People would have already scrapped them and moved on to a newer system and that type of stuff. So sometimes actually taking time to understand your existing system can help you build the next system. And you can actually, there are tools that will actually take existing systems and create diagrams from them. It's called reverse engineering. And basically, like if you had an existing database, you can basically read that database and it'll produce that diagram that we showed you earlier from that as you go through it. So what we're going to really concentrate on, and this is what the fact-finding piece for the rest of the night is going to be, is basically requirements discovery. How do we get people to tell us what they actually want inside of their system? So I have this problem. How do I get the solution out of my community as far as the users, the system owners, the builders, the designers, everybody else that's involved in this? How do we actually elicit those requirements from them as we go through it? So we're going to concentrate on fact-finding, and we're going to go through all of these techniques in the next set of slide deck tonight. As we go through it, we'll talk about interviews, we'll do sampling of documents, we'll basically talk about how you observe people in their work environment, that type of stuff. Again, at a high level, but it gives you a broad sense as far as what you can do. And I find that a lot of people that actually think about this, it's a great way to start a job too. Is go in and actually almost treat it like you got to discover what the requirements of your job are, because it gets you into the details as far as what your organization is expecting and that type of stuff too. Yep.
So like for us, especially when we start like our internships, it's kind of like I went there and then this is the scope of the project they want, and they asked me, I want you to do this, like it was current map, future map, gap analysis, action plan. So I know what all those are, but I don't have no clue where I'm supposed to start.
Right.
Whether like one of the things that I would have to look into, like start from.
So just hold on first, because we get to that next slide deck. We actually talk about how do you start getting those requirements, and a lot of it's just talking to people and figuring out what is, so they ask you to do this. There should be some baseline information that's out there, whether it's inside the organization or whether it's something exterior to the organization that you can go get and start that type of work. And that's essentially, that is the problem you get, is that it's like, hey, in here we give you very structured examples. You get into your internships and some of you are working, you already know this, they just give it to you and just say, hey, go figure this out, go do this, and it's up to you to figure out what the best approach is and how to actually handle it. And sometimes people can't deal with that ambiguity. It's like, well, what do you mean? I need direction. It's like, well, you need to get over that, because there's a lot of times you're not going to get all the direction that you desire.
Like, oh, we hired you. That's why we
right.
have a problem. Someone from what's your, I guess, expertise to figure it out. That's why we have it.
Exactly. Yep. So, and a lot of people, you quickly tell whether they can actually do that or not as we go through it. On some larger projects, you can actually pull everybody together. That's what a joint requirements planning is. You actually bring together kind of a cross-section of all the users and analysts and system designers and builders and owners and that type of stuff. You can get them, drag them into a room, and basically sit down and say, what does this thing need as far as the solution goes? This is actually with the data quality project I'm working on. This is what we did. We had, in the summer of actually 2014, basically pulled together members from about 30 different departments together and said, how in the world are we actually going to tackle the fact that we can't keep our information straight across all of the different systems that we have? And coming out of there, we had 6 recommendations, and that literally turned into a program that we're running at work and that type of stuff as we go through it. So, and then a lot of times what you're going to get into, too, is this idea that sometimes the business processes actually have to be redone. So they may have been set up at one point. Nobody remembers why we do things the way we do. It's just the way we do it. Sometimes you have to go in and just basically completely start over and redesign the business process as you go through and basically do your analysis. And that's typically called business process redesign, because essentially you're not paying attention to as much as what happened in the past, but more what should happen in the future. And then some other approaches that are just common out there, and if you guys interact with IT and that type of stuff, they may talk to you about the agile approach, which is really then this idea where you do a lot of prototyping and a lot of flexibility as far as building a prototype up front and basically solving smaller problems that are part of the bigger problem and show results really fast is kind of the idea behind that. And there's even their own language that goes with it. So they'll talk about scrums and sprints and that type of stuff. So like the one we're doing at work, really the agile method there is we take every 2 weeks, they're supposed to deliver the next version of our application. And so they add the next level of functionality to it, and then we keep adding on over time as far as what it can do and that type of stuff. So that's essentially kind of an approach that's through that too. It's just that you're doing all the different phases really, really fast and producing the next piece of it. So this is something you'll see again. So you want to, pay attention to these phases. So you'll see this on the exam and that type of stuff. So what is this? It says fast systems analysis phases. This is out of your book. They promote this this methodology called FAST. The professors from Purdue made it up, to be honest. But what it does is it does capture all the generic phases that you get with any approach. It doesn't matter if you're doing an agile approach or if you're doing information engineering or whatever your organization likes to do. You're going to go through all of these steps in some fashion. So the first thing is define the scope. Is this project actually worth looking at? What are we going to do as part of the project? What are we not going to do as part of the project? Then you have to go, okay, what is the problem here? Let's go and actually discover some of the root causes and that type of stuff. Let's really get down to the brass tacks around what is the problem in front of us, and then start to answer that question of, okay, we said the project was worth looking at. Now that we know more, is it still worthwhile to actually build a system that's going to solve the problem? Because you're continuing to make investments, right? None of this is free. So even to start the investigation in the project requires time and resources, attention, and that type of stuff. So because you don't have time to do everything in the world, you have to pick what's important and tackle that. So once you answer that question, then you're moving into the requirements analysis phase, and that's really what we're going to lean into over the next couple of weeks, and along with the logical design. And that's really saying, okay, what do we need in order to solve that problem? What does this new system actually have to do for us? What characteristics does it have to have? And then that extends into the logical design, so you're actually getting down to more detail around what should the system actually do. And then you use those items between your requirements together and your logical design to go through a set of solutions. You may be able to build it. You may be able to buy it from 3 vendors. You've got to make a choice around which one of those paths are you going to go. Even if you say, hey, I don't want to build it, I want to buy it, you got 3 vendors that may be offering you the almost equivalent product. How do you make that decision between the 3? And we'll actually give you a structured approach to doing that as well as we go through it. So the first piece that we are going to revisit here is just what is scope definition. And so what they do is they take each of your phases and they break it down into individual activities here that you can basically follow through the scope definition. So you can take a look at that. But basically what we're doing is saying, okay, what is the problem itself? Baseline it for me. What's the baseline problem? What's the baseline opportunity? Or what's the directive we have in front of us that we have to do? Remember, that's how we define a problem in here as we go through it. And we had that pieces framework around performance and economics and security, or control, I should say, all those types of things. We come out of that with basically a problem statement. Then we have to go negotiate the scope. What are we going to solve for? What are we not going to solve for? We have to say, is this really worth actively pursuing? And then we're going to basically put together a draft budget and schedule. maybe for the initial portions of the project, along with maybe some type of scope around, hey, in order to solve this, it's going to cost us $2 million, versus, hey, if we're going to solve this, it's going to cost us $10 million. You got to get down to that level of at least lining out that level of scope as we go through it. And then you've got to communicate it. And what comes out of that is your statement of work, which is that document, sometimes called a project charter, that basically says this is what the project is and isn't. Does everybody agree that we should go forward with the project and actually start it and kick it off? And basically, it's kind of like the idea of around charter, meaning I'm going to give you a charge to go do something in the organization. So go figure out this problem. So like one of the projects I worked on was, the charter was essentially go figure out with using information technology how to reduce our supply costs by 10% in the organization. So that was the overall charter, and then it had definition underneath it. It's like you can replace IT systems, but you got these limitations and that type of stuff too. And then, so from there, a lot of times what you're getting into is sometimes you'll actually have steering committees that kind of sit over top of your project. So like, for instance, the data quality one I have is an intersection of the C-suite. So we've got, leaders from the medical group there, the chief operating officer from the medical group, to our chief human resources officer, chief medical officer. They're all kind of sitting there and basically watching what's going on. And a lot of times you have this larger steering body, but you also have sometimes your project sponsors, or you don't sometimes have your project sponsors, you have project sponsors. The executives are really saying, hey, us as an organization, we're going to go do this. And if you ever don't have a project sponsor well-defined, get off that project. It's probably going to go nowhere fast, because you need some type of leader that can basically push your project through the organization whenever you do get into barriers. So for instance, with my department currently in the project we're running, my project sponsors are our CFO, our chief medical officer, and our chief integration officer. So those are my basically my executive sponsors, and then we have a steering body that basically loops together the rest of the organization so that we can knock down any issues that we have through there. They put in here that it's a steering body. I will with your steering committee much more. It's essentially what you run into. And then you have the project charter, and that's what everybody in your steering committee should actually understand, especially your project sponsors. They should basically understand your project charter, because that is your master plan that says, hey, here's what we're going to set out to do, and basically puts the boundaries around your project. Doesn't mean that stuff won't change in it because you're starting out at the beginning. You haven't even investigated the problem yet. But basically it says, here's what you can, or here's what you should be doing as far as your project goes. And so what you're going to do, and you'll see this in your project again as you go through it, is basically you're going to get into problem statements. And I'm actually going to provide you a charter. That's what's going to happen with your project, is I will give you the charter because I'm your executive sponsor. And then I'm going to have you go through and actually complete the projects according to that charter. And so sometimes, though, is you need to take that overall broader statement around, hey, I have this problem as an executive, and then start to break it down into its pieces. And that's what this document can help you do, is really start to walk through and say, okay, these are individual problems underneath that larger issue here. So here what they're trying to do is that order diagram we showed earlier. This company that does these mail order DVDs and CDs is trying to understand how can it improve its order process and its ordering system. It has an IT system that basically tracks all that. And you can see here that they've started taking that overall problem around inefficient orders, and they started breaking it down into individual problems as they go through it. And they're starting to do assignments here. What's the urgency to actually solve it? How much impact is it going to make to the organization from a visibility perspective, from a benefit perspective in terms of fiscal benefits, and then they end up ranking them, and then basically have a proposed solution that they think will work for them as they go through it. Now, the proposed solution is probably a little bit premature, but a lot of times you have speculation up front that people will do. So that's really getting your project charter in place, saying this is what we're going to set out to do. From there, you're moving into really the problem analysis. And here's where you're diving into the problem, and you're really starting to sort through the weeds. Like, okay, I've got this issue, they said, hey, run off and solve this problem for us. And they kind of lined out, hey, I want you to do, an initial assessment, a future state assessment, bring back the gap analysis, and tell us how to solve the problem. That's really what the problem analysis phase starts to let you do, is how do you understand the problem. And a lot of that gets into the requirements gathering as you go through it. So the first thing I like to do is, number one, do I even understand the content area? Because I can't solve something I really don't understand at the end of the day, right? Hard for me to walk into probably your job or, one of your other classes and say, hey, this is the solution to that answer, because I don't know anything about it. So what I find a lot of people want to do, though, is they get so enamored by the fact that it's like, oh, I got this new project, let's go do this. It's like, well, wait a minute, stop. Why don't you just take a day and just read through all the background material that you can get on the project? So you almost have to think of it as almost like conducting a research paper, right? So you're going to use Google, you're going to use your other research methods, find out who's kind of the authoritative voice in your industry around that individual issue. So like one of the things we had was patient flow. It's like, how do you streamline a hospital's efficiency as far as the movement of the patient from the point they get admitted to the point they get discharged. There are expert people in that field. You should actually go figure out what they're basically saying about patient flow. You should also, there are organizations and associations that actually just deal with that individual issue. There's conferences that you can go to, that type of stuff. So depending on the scope of your project, that's kind of one of the first things I would do, is basically start with the fundamental research. Get yourself up to speed and understand what the heck you're dealing with. So if I give you a patient portal, go figure out what's going on in the industry with patient portals. To me, that's your first step, is understand what's just the problem in general. And they call it the problem domain here. Then what you're going to do is you're going to take a step back and say, hey, now that I understand kind of the issue in the industry, and I know it from other people's perspectives and my own a little bit better, then what I can do is really say, okay, what is the problem and opportunities in front of me by solving this? Then I'm going to switch around and basically start looking inside my business, look at our business processes, look at how they're actually being conducted today, going through that. And then from there, what I'm going to be able to do is I'm going to start to be able to take that overall problem and say, hey, here are some system improvement objectives. How am I going to improve the situation in my organization in basically as sub-steps to that overall problem as we go to that? And then I'm going to go back to that overall charter or project plan that we have, and I'm going to update that and say, here are basically the improvements that we're going to make, and then move on to the requirements finding. So a lot of this type of stuff is really, again, it's research at the end of the day. So, you do the cause and effect analysis. So if you guys have had quality classes, right, I assume? You've done the fishbone diagram and that type of stuff? Yeah? No? Okay. We'll probably take a look at one of those. But really what you're trying to do is, a lot of times the problem that is given to you is actually a reflection of some type of other main issue. So sometimes what you're actually given to solve is not really what needs to be solved at the end of the day. It's more basically an effect of a cause. And you got to go figure out what the root issue is, what the root cause is as you go through it. The other thing that works really well with IT and other types of systems too is you can create context diagrams. And really they're just high-level pictures that show, especially with an IT system, what does it interact with? Who are all the users? What all departments actually interact with the system? What other systems put information into it and get information out of it at a high level? So this is more of a textual example of a system improvement document and a cause and effect document. This is something you'll have to produce for your projects as you go through it. But basically what you have over on the left-hand side is, okay, here's the overall problem or opportunity. Here's what we've identified as a cause and effect in the second column. And then moving to the right-hand side, we basically have, here's our objectives. And good objectives are actually written in a certain way. So basically they're SMART metrics. So they're specific, you can measure them, they're actually achievable, they're realistic, and they have some type of time frame to them. That's kind of what the SMART acronym stands for, if I get all that correct. And so a lot of times what I'm going to harp on you guys about is your system improvement objectives should actually have some numbers in them, and they should be realistic. And sometimes that's hard to even figure out what that is. But if you look at this one, the overall problem is that their order time or their order response time is unacceptable. So they've identified that as an organization. Hey, we can't get these DVDs to our customers fast enough. So that is the overall problem. Then they went through and they said, hey, here's the causes of that effect. Basically, we have an issue that we've actually grown because our throughput has increased, but our clerks were downsized. So essentially, we have an issue there. Hey, we have, our system that doesn't help us process our orders efficiently as we go through it. we have this old mainframe that basically is really slow. It's actually the third one, it looks like here, and they have an issue with their warehouse. So then what they went through and they said, okay, based on all that information that we discovered, so that's the problem analysis piece. They're coming back and saying, how are we going to fix it? That's what a system objective is basically, if we fix it, how are we going to, basically what benefit are we going to get out of it, or what should we expect from a solution as we go through it? So what you see here with the system objective is they're saying, hey, I need to decrease the amount of time required to process an order by 30%. That will actually help us basically get to the point where the order response time is acceptable. The next one here they have, and I'll just read each one of these because it's too hard to read on the projector, unfortunately, is they want to get rid of a bunch of the keyboard data entry. So they want to get rid of that by 50%. And you can kind of see they have a number attached to it, right? You just heard me say 30% first, 50%. That's actually something you can go back and actually measure and say, did we actually achieve our goal or not? And you actually, it's kind of interesting, as you get in organizations, you actually find some people that write goals in a certain way so they never fail. Like, they write them so ambiguous, it's like, well, yeah, you achieved your goal, but you can't tell heads or tails of what you actually achieved or not. And then they talk about how they need to, reconfigure some of their computer systems and that type of stuff. And then at the last point, they talk about how they need basically a new communication methodology in the warehouse. So basically, they can get away from their pick tickets that they have as they go through it. And then the other thing they put into it is they said basically what are they constraining by? So whatever they put into place long term as far as the solution, because we don't know the solution yet, right? We're just identified the problem, the causes of the problem, how we want to improve them as far as performance, but we really haven't said here's the solution that gets us that increase in performance. What they're saying is basically there's constraints too. So basically we can't have any increase in the workforce. You're not allowed to hire any new employees. So that's off the table. You might as well not even consider one. And that's actually pretty common. A lot of times there's not budget to put in new staff and that type of stuff as you go through it. They have some, the next one is more of a technical issue. It's like, hey, it's got to fit into our technology that we have in the company today. And then the last one is basically, hey, we already have some barcoding, and it's got to be compatible with the type of barcoding we already have for our warehouse. So those are constraints. And if you bring back a solution that violates one of those constraints, it's probably not going to fly. So you might as well not even bother, essentially, is what's going on here. So you've defined all of that. This is another diagram that we produced. Now, we kind of skip over this because we'll produce use case diagrams, which kind of provide this level of a diagram already. But this is sometimes good, especially if you're in a problem where you don't know much about the system. All it is basically it's called a context diagram. You stick your IT system in the middle, right? So here they have their member services system, right? That's that rounded rectangle right in the square in the middle. And then what it does is it puts all, I told you guys are going to be drawing stick people, right? So it's all the stick people around the outside of it. Well, what those stick people represent are people that are actually interacting with the system here. So, kind of going around the clock here, I'll start with potential member over here at this corner. And then moving around, we have basically past members, accounts receivable, the warehouse, the marketing department. We have member services and club members. And then what the lines represent is basically how do they interact with that system. What's the overall item that they're doing with that? So if we see a potential member, what can they do? They can start a new subscription. They can become a member. It's basically something they can do. What do they get from us? They get offers in the mail. So that's a business process. How do I generate the fact, if I'm Disney and I'm trying to get you to sign up for my DVDs, I got to get that offer in front of you somehow. So, in today's world, that may be by mail, maybe if there's internet, maybe instant messaging on your phone if you're a Disney member already. That process can take on many different forms, but that's the general idea. That's how you interact if you're a potential member with the system. If I am basically a past member, we're going to send something slightly different to you. We want to get you back into the club, but for some reason you left us. Maybe you were dissatisfied. Maybe you didn't want to buy any more movies at that time because you kind of already owned the Disney Vault. You love Disney for some reason. I loved it. Okay. Didn't try to say that. That kind of came out the wrong way. And then I was just in Disney in October, for a week. And then basically coming there with past members, what we're hoping that they do with the system is they come back and resubscribe, right? That they sign up. And that's a way to increase our business as we go through this. Very different, though, from the warehouse. What's the warehouse getting out here? They're getting all those orders of those DVDs. They need to actually have that pick ticket or that packing order that says, hey, ship this DVD off to Gale Theater in Racine, and make sure that information gets done. So, but what you can understand from this is a pictorial, right? But it's really easy to read. Anybody can sit down and pretty much read this diagram. You have half brain, so, or maybe even a quarter. You can basically pick this up. You can understand what the system is, what it's interacting with, as far as different constituencies within the company and also outside of the company too, as you go through it. So we've kind of talked through this. I'll just kind of go through these. So as you set up your objectives, what those are is measures of success. So if we go back to our simple cause and effect diagram here, those system objectives in that third column there, we're really telling us if we put in a new system, it's got to do all those things for us. It's got to reduce the processing time by 30%. Well, what that is that actually is a measure of success. That's how whenever we get the new system in, we're going to see if we're a success or a failure as we go through this. So it's something that you expect to be able to achieve with the new system. A constraint basically is the opposite. It tells you, hey, you can't solve that problem in a certain way. Whether there's rules and regulations from a legal compliance perspective, or whether you have to be able to deliver it by a certain date, or you have a certain budget amount, or you have to fit into a certain technology. That's what a constraint is at the end of the day. Essentially, you can't violate those constraints because it's not an acceptable solution. So kind of like what we just talked about. So as you go through with your group project and you start building your objectives and constraints, that's what I'm going to be looking for is, are you specific in your measures of success? Can you actually measure it, number one, and then is it actually somewhat realistic? And we're going to be making up a lot of stuff in here because I don't have a real project for you. It's not like you're actually working for, a company. You're going to be working for, like, Panther Memorial Hospital, which, doesn't exist. So sometimes we're going to be asking you to make that up, but I can pretty much tell you if your, measure is measurable or not. Because it's specific, it's got a number to it, it's got a time frame to it, that type of stuff as we go through it. And then a lot of times depending on how formal your project is, you may be asked to report out on those system improvements as well. Here's kind of a template around some of that stuff that you see in here as you go through it. I'm not going to harp on that. I'll walk you through what I want you to do for our project as we go through it. So then now we're into the requirements piece. So how do we actually do and gather the business requirements around this? So we've kind of gone through the problem. We said, hey, here's how we need to solve the problem, or what we need to expect as far as the success if we do solve the problem. Now the question is what really solves the problem? What are basically the functions that the system has to have? What are the characteristics the system has to have in order to solve the problem? So now what we're going to do is basically we're going to try to get people to actually tell us what those requirements are. Because a lot of times as a systems analyst, you're not the expert. And while you're kind of helping solve the problem. You're more like a facilitator and that type of stuff. And so you need to talk to the people that are the experts. And those experts typically exist in your organization. Like in Aurora, we have, specific people that do specific things. So we have experts in credentialing as far as dealing with provider information, if I go back to what I'm doing in my job right now. We have, people that are experts in how we deliver that information over to our commercial payers and how we enroll our providers in Medicaid and Medicare. So you might as well tap into their knowledge and get that because they're going to be the folks that are actually going to use your system at the end of the day and that type of stuff. So you're going to go through and actually collect these requirements and you're going to basically draft them into documents. Now, the way I do mine is basically we're going to do use cases. That's how we're going to document our requirements, and that's what we're going to do next week. I'm going to concentrate more on getting you guys through the diagram portion. There's also a document portion to that as well. But not all requirements are created equal, so you have to prioritize them because some things get you more bang for your buck if you solve for those. And then basically you have updates to your project plan. So the requirements kind of come in two shapes and flavors. Essentially you have functional requirements. This is really something that the system must do. So that's kind of the way I define those, and you'll have to define those on the exam as well. But basically a functional requirement is, think of it as something that the system must do. So it has to be able to process orders. It has to be able to do that electronically. It has to basically, see what else do we make up here? I have to be able to score an application in a certain way. If I'm in HR, it has to be able to do payroll that meets these standards. It's an HR system, those types of things. So basically, a functional requirement is something that the system must do. Or here it says the activities and services the system must provide. A little bit different from non-functional requirements. Non-functional requirements, think of it as more a characteristic the system has to have. So those are things such as, hey, it's really easy to use, and it's got to be that way. So actually, that's one of the systems we just launched at Aurora. What I put out there on January 4th. We spent a lot of time on making it easy to use because we had so many people with different types of caregivers using it. It was like, this just has to be kind of self-explanatory. Plus, a lot of people don't have time for what we're asking them to do, so it better be fairly easy to do. Or, you know, it's got to be a certain speed, otherwise people won't use it. So, you know, you can't have a slow medical record system because if I'm a doctor and I'm trying to interact with my patient and I'm always filling with a computer, that's not acceptable at the end of the day. I need it to be fast in performance so I can get the information that I need so I can actually spend time with my patient. A lot of times in today's world, security is a big aspect of things too. So for instance, if you're putting patient data into any system, it has to have certain security requirements. It has to abide by HIPAA and the HITECH Act and those types of things, and have certain levels of encryption and passwords and all that fun stuff as you go through it. So what we're going to do is we're going to wrap in basically this first piece around functional requirements. We're really going to do what we call use cases. And this is one of the UML diagrams out of the 13 that there are. We're going to go through and basically do use cases. And what a use case is it's a way you use the system. That's why they call them use cases. How do I actually use the system? So when we do the ATM example next week, I'm going to ask you, how do you guys use an ATM? You're going to have to step back and think about it and go, well, I never really thought about that before. I just used it. Well, yeah, but now you're designing the system. You actually have to define that. And so we're going to do that together in class with each other as we go through this. So, and some of these projects are massive. So think about Epic, it's a Wisconsin company. It's right west of Madison and Verona. They have to actually sit down and think about how are the different ways that a healthcare company wants to use a medical record system. That's a gigantic system. But they need to, even at the end of the day, they have to boil it down to that level and say, what are all the different ways that you can utilize a medical record system within a hospital environment, within a clinic environment, within pharmacies, within those environments, labs, that type of stuff as we go through it. So this really goes hand in hand with the object-oriented analysis as we go through it, and this is kind of what it looks like. So this is actually one for a restaurant. We'll go much more into detail about this, but you see, again, 6 people. I'm telling you guys on the 6 people. They're fun. So as we go through it, but here we have a restaurant system. All the different ways that they use the restaurant are basically in the middle. So that box represents the idea of the restaurant. All the people interacting with it are basically the chef, the waitstaff, patrons. We have the cashier, and we have different processes or different ways of using the system. So like the cashier and the patrons together, they collaborate at the bottom oval down here, and that's how we actually process the transaction that they pay for their dinner and that type of stuff. So we'll go in much more detail around that. Time boxing is essentially, a lot of times what you want to do is actually say, let's actually figure out how do we produce a small version of the system and actually do what's called time boxing, which says, hey, let's put out the first version in 30 days and actually go through and try to solve some of the smaller problems and actually get something out there. Kind of goes hand in hand with prototyping as we go through this. All right, we're getting through the systems analysis piece here. So the next piece of this is really getting into logical design. And this is essentially where you're going through and you're taking those requirements and you're starting to figure out how are you going to design a system that actually meets those requirements as you go through it. And so you're taking each one of those pieces and you're basically designing the overall system, and that will flow into basically the decision that you have. And we'll get more into these pieces later on, but that's essentially where we're leading to, and that's what your project will take you through as you go through this. And with the decision phase, really what you're doing is you're saying, hey, I've collected all the requirements, I've done my design as far as what the solution should potentially look like. What are we going to do from here? What should the company do? This is where you become a salesperson and really start to do your sales pitch and say, hey, we've done all of our research, we've done all this hard work and analysis. Here's our overall recommendation. How do we, can we actually get the system owners or the executives in our company to actually carry that out as we go through that? And we'll look at all these in detail, but basically we're going to address each of those solutions and score them in different ways. What does it look like from basically a technical feasibility? Does it actually work with our existing technology? Do we have the technology to actually carry it out? How does it actually will it actually fit well into our own company? Not all systems work in every company. Sometimes culture gets in the way, and some systems don't work. Or sometimes the work environment makes basically a system infeasible as far as it goes. Economics is always an issue. Do you have the money to pay for it, and is it going to produce enough return on investment to actually warrant us to actually do this? Can we actually put it in place by a given time period? Something else that you'll be producing for your project then is you'll actually go through and start to propose a couple of different ways to solve the overall project. A lot of times in here we get into a build versus buy. Are we going to build an IT system or are we going to buy it? And we go through and we basically start to score the systems that we're proposing against each other on these different items. And so it really comes in two flavors. You have this candidate systems matrix, which really is a lot of the characteristics of the systems and kind of set it side by side so you can make that comparison. What's nice about this is if I'm the executive and I have to sit down and look at this, it's all cleanly delineated, right? I can just run down this and quickly see what the inputs around each of the candidate solutions as we go through this. Then you get into a little bit more of a formal feasibility matrix, and you guys will definitely have to produce this. This is where you take each of those things we just talked about as far as feasibility, you actually go through and score it. And you say, okay, this is how well it fits into our technical environment. This is how well it will work in our existing work environment around the organization. Here's a kind of a fiscal scorecard. This is the return we expect, and this system outperforms the other system from an economic standpoint. Here we have a schedule feasibility. We can basically get that system in and get value from it sooner than later. And you basically wrap all of this up into a system proposal, which is basically your group project, what you're going to be producing. And I have a template that I'll kind of walk you guys through it. And that is kind of systems analysis 101. Kind of all that gamut from what is the charter, what are we trying to set out to do, to how do we get to the point where we actually have a proposal on how to actually solve it. So that is really the crux of the semester and what you're going to have to produce in this class, is that overall system proposal. And in order to get there, you've got to do everything we just ended up talking about in the last hour or so. All right, I've been talking for a long time. Let's actually take a break tonight because we'll get into the videos next, and I want to try a couple things out. So why don't we kind of come back in about 10 minutes. I'm going to cut the recording, and then I'll start it back up. But let's take like a 10-minute break. Everybody be back at, it'll be 6:50 then. Thanks, guys. And for those of you online, you can just stay online, and I will basically just start this back up with the recording when the time is ready.